Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. Okay, so today we are going to discuss, please refer to your tutorial book. We will look into discuss on the question of topic 10, tutorial application of differentiation. And this on the page of, we call that current page, copied from we call our tutorial book. And I had chose a few questions, so I do hope that all of you may continue with the rest of the questions and complete the task and continue with the SPM of last final examination questions. Okay, so I chose the first one here, and let's continue with the question of A here. Okay. Use the first derivative test to determine the relative extremum point for the following here. Number 2a. So then y equal to x cubed minus 12x. And then use the first derivative test means that we will differentiate once only. Y prime equal to 3x squared minus 12. Then we make this one y prime, make it equal to 0. And from here, 3x squared minus 12 equal to 0. Let's bring this to the side. Then 3x squared equal to 12. And x squared equal to 12 divided by 3, which is equal to 4. Then x equal to plus minus 2. Okay, class. This is cubic function, power of 3. So is either will be something like this, let's say y and x, a graph something like this, or maybe this. Okay. Okay. The difference between these two is this we call with the gradient which is positive, gradient negative, and positive. So we get a maximum point of the curve. Maximum and also minimum, or might be the graph come out with the minimum first, with the lowest point here, the value of this, and then come out with the curve of this with the top or high, we call maximum of this. Okay, either one, let's try. When x equal to negative 2, so then when x equal to negative 2, let's substitute into the y here. Y with negative 2 equal to negative 2 cubed minus 12 times negative 2. Then negative 2 cubed equal to negative 8. And negative become positive. 12 times 2 is 24. So 24 minus 8, 16. So it's a coordinate of negative 2 and 16, and y when x equal to 2 y here, okay, 2 cubed minus 12 times 2, which is 8 minus 24, then come up with negative 16. Okay, now actually that we plot the coordinate from this, we can substitute the x equal to negative 2 and 2 into the function of y or fx. We determine the coordinate, okay, which is 2 and negative 16. So now, from the first derivative test, let's use the table here. Okay, x cubed, we divide it into two parts here, where the x equal to from x negative 2 until 2. So we get what we call 3 areas of territories here, 1, 2, and 3, which the first territory is from negative infinity until negative 2. Then here from negative 2 until 2, and 2 up to positive infinity. So we get first one here, negative infinity until negative 2. Then negative 2 until 2, and 2 to positive infinity. Okay, so just imagine that this is the coordinate we call point of x for negative 2. Here, negative 2. And also x equal to 2 here. From the y of x cubed, if we can factorize, we may factorize this one. Do we need to factorize this? No. Okay. And then substitute with what we call f prime x of f prime x or y prime, and also the sign of y prime. The sign of y prime, we are going to look into the sign of positive, negative, or positive or negative based on we call the value of y prime. We substitute any values in between here, and we get the gradient is either positive or negative. Okay, now and let's choose any values of x that lies in this range from negative infinity until negative 2. So this is negative 2 and this is 2. So and any numbers that lies from negative infinity until negative 2, we choose negative 3, for example. Okay, let's say if we x equal to negative 3, and here make our life easier. I choose 0, x equal to 0, and here is x equal to 3. Okay, so let's come up with y prime. Y prime, value of x, negative 3. Okay, 3 negative 3 square minus 12. Negative 3 square equal to 9. And 9 times 3 equal to 27. 27 minus 12, 7. 27 minus 12, which is 50. Okay. Wait. Got something there. Okay, sorry, I suddenly recall, forget the value of this, which is 15, meaning the value of this is positive 15, and then positive 15 y prime where x equal to 0. You may choose negative 1 or equal to 1 because negative 1, 0, and 1. Any numbers that lies in between negative 2 until 2. But make our life easier, choose 0. So when 0 here, this one, 3, 0 square minus 12, of course here comes 0 here, equal to negative 12. Negative. And then y prime, where x equal to 3, x equal to 3 here, and 3 square minus 12, 3 square is 9, 9 times 3 equal to 27, minus 12 equal to positive 15. Okay, positive, negative, and positive. So the sign of positive sign of y prime here, positive, the gradient of positive, negative, and positive. So this is a sign of gradient. Okay, so we may imagine how the graph looks like. The graph moving up, Okay, stop now around here, 10. Okay, now the sign of this one means that the gradient of the curve, which is positive, the gradient of this curve negative, and gradient of this curve, which is positive. So then, the coordinate of the maximum here, this is it. Okay. This is the gradient. This is the maximum point of -2 and 16, and the minimum point here. Okay, when y(x) equal to 2, y is 16, 2 and -16. The lowest point when y equal to -16 here. Okay, so the question will find us use a federative test to determine the relative extremum points, which is, okay, here -2, 16, and 2, -16. Given that y -1, 5 is a stationary point on the curve of y equal to x squared, it's a quadratic. Okay, let's refresh our memories about the topic of quadratic for function and graph. Y equal to ax squared plus bx plus c. Okay, the curve is whether small curve or set curve. Okay, quadratic of 2, and then this is for when a is greater than 0, and this is a less than 0, with a minimum point and maximum point. Now, given to us the y equal to ax squared plus bx minus 4, and given one of the stationary point here is -1 and 5. So then, substitute -1 and 5, y equal to 5, and x equal to -1, a -1 squared plus b times -1 minus 4, then come out with -1 squared equal to 1, a plus b minus 4, then a plus b equal to -4, bring it become positive 9. So then let's make this one as an equation 1, which I think that, okay, -1 squared equal to 1, negative times b is supposed to negative here, sorry. So then, okay, so also here, a minus b, so -4, bring it to the side, become positive 5 plus 4 equal to 9. Let's make this on equation 1. Okay, we mentioned there is a stationary point on the curve, so it means that we're talking about the y prime or dy dx equal to 0. So from this equation, then we come out with, okay, y equal to ax squared plus bx plus c. So differentiate this, come out with 2ax plus b equal to 0. And then, substitute with x equal to -1 again. Here, we don't have any y, so then 2a times -1 plus b equal to 0. -2a plus b, -2a equal to -b, then a equal to negative positive, then b divided by 2 or b over 2. Equation 2. Substitute equation 2 into equation 1, which means that we have value of a here, substitute with b over 2 here, b over 2 minus b equal to 9, 1 over 2b minus b, come out with is just like a half minus 1. Negative 1 over 2, b equal to 9. Then b equal to negative 2 right here, negative 18. Okay. And substitute b 18, negative 18 is either equation 1 or equation 2, up to you. Okay, b equal to negative 18, substitute into equation 2 here, where a equal to negative 18 divided by 2 equal to negative 9. So then, find the values of a and b. A equal to negative 9, b equal to negative 18. Then you substitute, find out the complete equation of this quadratic equation of this one here. Okay, but then the question wants us to find the value of a and b. It's not write down the complete function of y. It's all up to you then. Use a second derivative test to find the coordinate of local extreme of the curve. Fx equal to x cubed minus 6x squared plus 9x minus 3. Use the second derivative test, means that we're going to differentiate this function twice. Okay, so f prime x equal to 3x squared minus 2 times 6 equal to 12x plus 9. Then f double prime x, or second derivative, 2 times 3 equal to 6x minus 12. Okay, so from the first derivative test, we're going to find out the value of x. The value of x from here, let f prime x equal to 0. Okay, because x cubed means that the graph, let's say this x-axis, the graph will be something like this. Okay, or maybe this. Okay, so you have three values of x. The curve cuts at axis at 3 points here, 1, 2, 3, and also here 1, 2, 3. So let's say this x1, x2, and x3. Same goes to this one here, x1, x2, and x3. Okay, okay, this x1, x2, and x3, we are referring to this function of y, because it's curved here. We might come up with 3 linear vectors to get this x. For f prime, we can look at this point here, whether the curve, okay, look at this one here, the gradient is positive, negative, and positive. And also here, the gradient is negative, positive, and negative. Okay, so f prime, we are referring to the gradient of the curve, positive, negative, or might be negative, positive, negative. So we need to find out this one here. Let f prime x equal to 0, 3x squared minus 12x plus 9 equal to 0. So then factorize this. Before that, which I think that we can simplify this. Then divide by 3, come out with x squared minus 4x plus 9 equal to 0. Okay. And then x and x, 9. What about this one here now? It's supposedly 3, sorry. Okay, 9, 4, 3, 12, and 3 here. 3 x minus 1 and x minus 3. X squared, negative 3 with negative 1, negative 4x, negative 1 times negative 3 equal to positive 3. Meaning, use the second derivative test. We substitute the value of x equal to 1 and x equal to 3. Substitute these two into the function of f double prime. Okay, f double prime x equal to 6x minus 12 when x equal to 1 when x equal to 1, and this is a question of number 5. Question number 5. Question: when x equal to 1, substitute into the function of this f double prime 1, which is 6 times 1 minus 12. 6 minus 12, negative 6. So we come up with the conclusion that is a relative maximum. Okay, and then f double prime from x equal to 3 here, then 6 times 3 minus 12, which is 18 minus 12, and come out with equal to 6. So we come out with a conclusion that is a relative minimum. Okay, so we need to find out the coordinate of relative maximum and minimum here. Then we use the function of fx from x, now 1 and 3 here. So f1 equal to 1 cube minus 6 1 square plus 9 times 1 minus 3. So 1 square is 1 times 6 equal to 6. 1 minus 6 plus 9 minus 3. 9 minus 3 equal to 6. 6 minus 6 equal to 0, then 1 here. Then we come up with a coordinate of 1 and 1. And then fx, where x equal to 3. 3 cubed minus 6 times 3 squared plus 9 times 3 minus 3. Okay, 3 cubed 27. 3 squared equal to 9. 9 times negative 6, negative 54. 9 times 3, 27 minus 3. 3 cubed 27. 27 plus 27, 54. Minus 54 equal to 0, then negative 3. So we come up with the coordinate of 3 and negative 3. So from this, we go from here. Let's see how the graph looks like. Okay, when we substitute f with 1 and 1 here, means that we look at the coordinate of 1 and 1. Okay, and then coordinate of negative 3. Coordinate of negative 3 and negative 3 here. Okay, so relative maximum relative maximum when x equal to 1, relative maximum here. So graph will be something like this. Okay, So this is the peak and this is the lowest point. Or how can I say this one here? Sorry, bad sketching. There you go. Okay, let's have it like this. Before x, okay, x less than -3, from up x -3 to -infinity. Say that the gradient is negative. From -3 to 1. -3 to 1, the graph, the gradient is positive, and after that, from 1 to positive infinity, the gradient is negative. There you go. Okay, so use the second derivative. So second derivative test is all here. Okay, we come up with the conclusion is a relative maximum because we substitute the value of x into the double because second derivative, we get negative, so relative maximum, and then we substitute the 3, we get the positive, is a relative minimum. So this is the conclusion for the second derivative. Then we find the coordinate of the lowest point and the coordinate of the lowest point, 3, -3 here, and the coordinate of the peak or the maximum, which is 1 and -1 here. A rectangular box with open top. Okay, rectangular box, open top, formed to be a rectangular piece of cardboard, meaning that we are going to cut a piece of cardboard, a rectangular piece of cardboard, maybe something like this, rectangular. And then, to make a cardboard, a rectangular box, open top means that from 3 times 8 here, from 3 times 8, then we need to cut what size square should be cut from each corner, meaning that, let's say we cut here x with an x, and also here x, 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 and x. Okay, so we are going to cut the square at each corner here to form the box with the maximum volume, meaning that class, from here now, from here, then we come up with this one. Okay, and then we are going to fold this part, then we get something like this. You get it? Okay, now from this side 3, then we minus with this x. Okay, minus x and also x. Cut x here and also here. So it is now become 3 minus 2x. And also here, we cut x here. We're going to cut x here. And also on this side here, so this one come out with 8 minus 2x. So now, this is 8 minus 2x. This is 3 minus 2x. And this height, which is x. Okay. With a box with a maximum volume. So then V equal to 3 minus 2x times 8 minus 2x and multiplied with an x. Okay, 3 times 8, 24, then times x, 24x. 3 times 2x, negative 6x squared. 3 times negative 2, negative 6x, and now multiply x, x squared. Negative 2x times 8, negative 16x squared. Negative times negative, positive 2 times 2 equal to 4x cubed. So then 4x cubed. Negative 6 minus 16. 3 times 2 equal to negative 6x and x squared. Negative 2 times 8, negative 16, x times x. Okay, minus 22x squared plus 24x. Then v prime dv dx equal to 4 times 3 times 4 equal to 12x squared minus 44x plus 24. Then v double prime equal to 2 times 12, 24x minus 44. Okay, so now we are going to find out, recall the value of x from this v prime. Let's make this v prime equal to 0. 12x squared minus 44x plus 24 equal to 0 divided by 2. 12 times 4, 48, but we have here is 44. Make this one here as 6x squared minus 22x plus 12 equal to 0. Okay, is if I choose using this one here, because we should use the calculator, x equal to negative b, negative times negative 22 plus minus square root of b squared, negative 22 square minus 4a and c, which is 12, divided by 2a, which is a equal to 6. 22 plus minus square root of, okay, then I use a calculator. You may use we call the quadratic equation in the calculator to find the value of x. But then here now, 22 squared. Okay, 484 minus 4 times 6 is 24 times 12. 288 and divide by 12. Okay, square root of 484 minus 288 equal to 14. 22 plus minus square root of 484 minus 288 equal to 14 divided by 12, which means that here it is either 22 plus 4 plus 14 divided by 12 or 22 minus 14 divided by 12. Okay, so then 22 minus 22 plus 14 divided by 12, 36 divided by 12, and divided by 2, and divided by 12, which is 3, and then 22 minus 14 equal to 8. 8 divided by 12. 8 divided by 12, 2 over 3. Okay, from these two values, we come out with conclusion that is x minus 3. Okay, from here, we call x, then 3x minus 2. Is that it? Okay, never mind. You please find it yourself, because 3x times x, it cannot be equal to 6x squared. Never mind. Okay. You please find out yourself by yourself what is the value, what is the, what you call, the linear factor here for these two. Okay, because I found out the value of x from using the formula, so I'll not to discuss much on that, this part here. Okay, x equal to 3 and 2 over 3. Substitute these two values into v double prime. So v double prime when x equal to 3, v double prime here from these two values of x that we get from v prime. Okay, from v prime, and then we substitute into the formula, we get these two values, substitute into double prime, because second derivative, v double prime equal to 3, 24 times 3 minus 44. Okay, so 24 times 3, 72. 72 minus 44, 28. 28, which is positive. Okay, so we come up with a conclusion that is a relative minimum. And then v prime, v double prime, when x equal to 2 over 3, then 24 times 2 over 3 minus 44, 24 divided by 3, 8, 8 times 2 equal to 16 minus 44, 16 minus 44, negative 28. So with negative here, we come up with the conclusion is a relative maximum. Okay, meaning we're taking the value of x equal to 2 over 3 to get the maximum volume for this box. Okay, so then the answer is x. So then the answer is x equal to 2 over 3. Okay. Let's continue with question here. I skip one of the question because it's similar with the previous one. Okay, it's still a box. Let's start talking about a box then. Okay, question 13. The size in centimeter cube of a tumor in radius r is given by v is mentioned here. Find the rate of increase on size. Okay, this is the formula of sphere. sphere is different from circle. Okay, class, if a circle, we're talking about the ring of a circle. Okay, but then when you come to a sphere, okay, by this one here, we're talking about the ball. For example, it's a three dimension, we call dimension. Okay, we have the radius between, and also ether. You just imagine it's a ball, it's not a ring or circle. Okay, so given that V equal to 4 over 3 pi r cubed. Okay, let's take a look. Okay, the size is given, then V here. Find the rate. The rate means that the changes of something respect to the time. Increase in size. Size of the we call the tumor in the for this one here, volume of V equal to dV and dt. Okay, this is a formula then. Okay, so we're talking about the changes of increase in size. Size in this case, we're talking about the, we call the size of this tumor in shape of we call sphere. So from time to time, it's going to be called increase or bigger getting bigger and bigger. Okay, now it's mentioned here, find the rate of increase in size or volume here, and may given that dr dt, so dr dt 0.03 centimeter per month. So we're going to find out what is the dv dr here. Okay, dv dt, dv and dt here changes respect to the radius and changes of radius respect to the time per month here. So we're going to find out this from here. So then dv dr equal to 3 times 4 over 3 pi r squared. 4 pi r squared. So we substitute, it's all here then. So the question is very, not very difficult, it's easy then. So dv dr is given here, which is 4 pi r, where r equal to 0.9 square, and then dr dt equal to 0.03. Okay, so 4 pi r square dv dr, and dr dt is given the question here 0.03 centimeter per month. So you may strictly use your calculator here. 4 times pi times in bracket 0.9 bracket square, and multiply with the bracket of 0.03. It gives you, what I get here is 0.30536. So in 1 decimal places, look at this one here, 0, and the next is 5, so you come up with 1, it is 0.31 centimeter cube per month. Okay, now the total cost of manufacturing M boxes of actually set is given by this one here, the function of C, the total cost of manufacturing M box, the numbers of M boxes, and also M with a constraint of time, TQ plus the TT. Okay, compute the rate, again, the changes of something respect to the time, the rate of change of total cost, dc dt. So we come up with a, we call formula of this, dc and dt. Now, it's time for us now to find out what is the changes of cost with respect to what. What we have here, the variable of m is the numbers of boxes, m boxes, dc dm and dm dt. Okay, now, when given t equal to 2, when t equal to 2, let's substitute here m2 equal to 2 cubed plus 30 times 2. 2 cubed equal to 8 plus 30 times 2 equal to 60 equal to 68. So let's find out the dc dm of this. dc dm equal to 3m squared minus 6m, and the changes of the number of boxes with respect to the time, which is 3t squared plus 30. Okay, so when t equal to 2 here, when t equal to 2, so then dm dt equal to 2 squared plus 30. 2 squared equal to 4, 4 times 3 equal to 12 plus 30, which is 42. Okay. Okay, class, I found out this mistake that I made it here. This is dc dm. This is the c with the variable of m, 3m squared plus 6m minus 100. So I have no idea. It's supposed to be dc dm equal to 2 times 3 equal to 6. Okay, I make a mistake here, sorry. Sorry. Okay, 2 times 3 equal to 6m plus 6. Okay, so dc dt equal to dc dm multiplied with dm dt. Okay, when we m equal to 68, okay, t equal to 2, we substitute into the formula, the equation of m. We got numbers of m boxes constrained with the time of t here. We substitute t equal to 2, then we get 68. Now we substitute 68 into here. Okay, so when t equal to 2, m equal to 68, then shall I bring that here? I write down here then. Okay, dc dt when m equal to 68, which is 6 times 68 plus 6 equal to, okay, 68 times 6 plus with 6, 414. Okay, then we substitute the value of 414 here. 414, and then dm dt equal to 42. So 1414 they multiply with 42 equal to 17388. Okay, so the question, total cost, compute the rate of change equal to 2 here, dc dt equal to 17388. Okay, so I think that that's all the questions that I select for our discussion in this video, and I do hope that all of you please do continue, complete the task of all the question from tutorial and also the question from the collection of past year question. That's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh and have a nice day.